Okay, in this next video, we're going to talk about returning pointers. Okay, so you can return pointers. Notice how this says a return type of int star, which means you're returning a pointer to an int. But when you return pointers, you have to be careful what you return. Make sure that the address of the variable that you're returning still exists. What does that mean? So if you create a local variable, you know by now that the scope of the variable in the function is gone after the function is done. So age is a local variable. When you leave the function, age is deallocated and released to the operating system. So age is not your memory anymore once you leave the function. So if you return the address of age, it will go back, but then that address is not yours and you won't have good data in it. Okay, so the same thing when you're passing parameters and you're trying to return the address of the parameter. It's the same thing because when you pass by value, remember you're getting copies in here. Unlike what we just saw with int arrays, this is very different. In int array, the address is getting passed by default anyway, by reference. But that's not what's happening here. X and Y are being passed by value. So what are we doing in this program? We're trying to find the minimum of the two values and use a function to return it. But we are trying to return it using a pointer. Okay, so we are passing x and y to the function. We're also passing a pointer called min that can hold the value or the address of that minimum variable. But here's the problem. So we call this function, min is a pointer. Okay, so we receive the return value into a pointer. That part is fine. We pass x and y by value. So when x and y gets copied in here, we can find the minimum of the two, which is not a problem. But then what we do is we find the minimum of the two and we take this, our local copies, remember? And we take the address of the local copy and put it in min. Remember, when we leave the function, these two are going to be gone. Okay, and this min is also a local variable, but that pointer is getting returned. Okay, which is getting returned and is getting copied in here. That is fine. But the address that is bringing back is the problem. The address that is bringing back is going out of scope the minute we leave the function. So take a look at this and copy this and put it into our Python tutor. Now, if you do this, you will get some results, but it's really not consistent results. Okay, and I'll show you why. So if you visualize execution for this code and see in memory what's actually happening to these parameters and the address, right? So here's X and here's Y. They are getting some values. They are in main. And then here's my min pointer, which is pointing to null. That means there's nothing it is pointing to. It's not pointing to anything. Then you call this function. Notice here's my function in memory. X and Y are different memory locations in the function. And when I hit next, notice values of X and Y from main are getting copied into the function. We all know this by now, right? We know functions. So they're getting copied into X and Y here. Min is still null. This is a different min in the memory location. So then we check, and if x is less than y, which it is, 5 is less than 10, we take the address of this x and put it into min. So min is pointing to this local x in the function. And then we return min, and min comes back. Function is gone, x and y are gone. And notice that little emoji. That means it's garbage, right? There's nothing it is pointing to. And when you try to see out, we are going to get an error because that address that min thinks it's pointing to does not exist anymore. So what is the right way to do this? If you are going to return a pointer, make sure that pointer is pointing to something valid. Here's another thought. Why don't we pass x and y as pointers? Receive it as pointers, I should say. Okay, so let's receive it as pointers. Pointers referring to what main has. Okay, so xptr and yptr, they are addresses. Let's send them the address of x and y from main. Okay, if we send them the address of x and y from main, then we are essentially referring to this address that's in main, and that's not going away anywhere. And then when we come here, min equals not ampersand x, but xptr, the address that xptr has, the address that yptr has, which is really the address of x and y from main. So we are safe because then these values don't go away anywhere. And xptr and yptr will go away, but remember, we copied into main, we return, min, and we return min, which gets copied into main. So the address pretty much that comes back is safe because the address coming back is x and y's address. And to do that, we are passing it using pointers. Okay, the other way you could do this is to pass x and y by reference and min by reference, and do it that way as well. So let's take a look at this and see if this does us any good. Okay, so now that I've converted these to pointers, I cannot compare x and y. So I have to compare the value of xptr, which is really the value of x in main, compared to the value of yptr. Remember, we need to dereference our pointers and say if the value of xptr is less than the value of yptr, which is the value of x and y in main, because really these two are pointing to that, okay? Then I want to say min equals the address that is in xptr. So this is just the address. That is not the value. Dereference it, put the asterisk in front of it. That is the value to compare. And remember, we do need to put xptr. We need to send the address back because min is a point. Think about some of these things as you trace this code. So there is that. We know how that works. Okay, here's where we are receiving everything into xptr and yptr. Min is still null. So notice now xptr and yptr are referring back to main, okay, which doesn't disappear anywhere. And then we compare the values. 5 is less than 10. So we copy the value that's in xptr, which is the address of x, into min. Notice now min will also point to x. It's kind of hard to see, but you can see min pointing back to x in main. And then when you return it, that min gets copied into the min in main, and that is pointing to 5, which is there as well. Now this should bring up this question of, can I pass a pointer by reference? In this case, the pointer is being passed by value. So I must return it. If I don't return it, nothing comes back to main. And I return it's the pointer type. Can I return a pointer by reference? Sure. So make this a void function. And instead of returning the pointer, send the pointer by reference, which is just like sending any other variable by reference. And it works exactly the same way. So run it. And so I shouldn't be receiving anything. Take that out. Notice it's telling me that it's a void function. I shouldn't be returning anything. So now when you take a look at it, the pointer is being passed by reference. And so any changes that's happening to the pointer in the function will actually be reflected in main. So there is all the pointer. Notice this pointer is being passed by reference, so it automatically points to null in main. It's still null, but notice it's pointing to null in main. And then when I try to assign a value to it, now it is pointing to 5, which is xptr. So if you go back to the previous one, notice the change. From null, it is pointing up to 5. And then when we go back, min is now pointing to 5, which is a smaller value. Okay, so you can try some of these things. Take away the reference, for example, and take away the return, right? And you will notice that nothing is going back. So this is a case where nothing is going back. Min is being copied. Sure, it's being assigned the value here, but then when the function ends, min is not going back. We lose the value of min, and this min is still null, and your program will crash because you're trying to output a pointer that is not pointing to anything. So try it and see what happens.